Hi, here's integration by parts practice problems using the indefinite integral part 4. So first of all, I understand that there's tons of tutorials out there for the same thing, and therefore if I can't be a help, I'd highly recommend you checking out Professor Leonard, who is an extraordinary supplement to my calculus classes, Professor Dave Explains, Organic Chemistry, Tutor Patrick JMT, and such. I'm fully aware that I may not be able to reach through every single person watching this. I'm definitely not proclaiming that I found a breakthrough in teaching, nor am I the best tutor in the world. I just simply want to help out the best I possibly can. Teaching is my passion. So let's get started. The formula, which I derived in a previous tutorial, says that the integral of u dv equals uv minus the integral of v du. Okay, so this u dv is this right here, or the integrand here is this integrand right there, and it's going to equal uv minus the integral of v du. Well, that's great, but what's the u and what's the dv? Well, that's for us to pick out. Our u, we want our u to be something that we could differentiate easily, and our dv to be something that we could integrate easily. And in this case, both would work, actually. So I tried it myself, and if you set u to be ex and dv to be sin x dx, then it works the same way if you had chosen u to be sin x and dv to be e to the x dx. So it doesn't really matter. If you want more trig functions, you would set u to be sin x. If you don't like trig functions, then set u to be e of x instead. And it works both ways, but I'm going to choose the exponential to be the u. So we're going to choose our u to be e of x, and our du would be its derivative, which is ex dx. If that's going to be our u, then our dv will be what's left over, which is sine of x dx, and therefore our v will be negative cosine of x, because the derivative of negative cosine of x is negative sine of x, and two negatives make a positive, so that checks. And I again would highly recommend you using this this pattern right here to set it up like this: u, du, and dv, and v like this. That's how I was taught. That way you could just simply draw arrows, this one first, then that one. Okay, and that way it could direct you to set this equal to u times v, okay, minus the integral of v du. So for this type of problem, and you'll see why I'm doing this towards the end, I'm just going to go ahead and write the original problem here, and I'm setting that equal. So this is the integral of u dv, and I'm setting that equal to u times v, which is negative e to the x cosine of x, okay, u times v, minus the integral of v du, which is going to be negative I'm just going to put negative e to the x cosine of x dx. It means the same thing. But since there's a negative here, I'm just going to go ahead and pull that negative one out, and I'm going to change that into a positive, or that would consequently change that into a positive. E to the x cosine of x dx. Okay. Now we can't integrate this easily. We have to do integration by parts again. Now if you have to ever do integration by parts a second or a third time, always keep u the same as what you chose here. For instance, I chose the exponential to be u. I have to do that again. I tried it just to check it out. I invite you to check it out. Set u to cosine of x and see that you wouldn't get to the answer that way. This will cancel out with what that would equal, and you would have this equaling that. Again, check it out, but if you have originally u equaling to the exponential, you must have u equaling to the exponential here. You can't like switch switch up the problem like that. So therefore our dv is going to equal what's left over, which is cosine of x dx, and therefore our du is going to be the derivative of our u, and v is going to be the integral of our u, which is sine of x. Now, sine of x, the derivative of that is cosine x dx, so it checks. Okay, and now the same thing, we're going to set this and just this right here equal to u times v minus the integral of v du. And I'm going to copy everything down here to avoid error, to avoid mistakes. So I'm going to add what this equals, and again this equals uv minus the integral of v du. So you could do parentheses if you want. I'll just go ahead and write it out. So that's u times v minus the integral of v du Now, does that get us anywhere? Because it seems like we're going to repeat integration by parts over and over and over and over and over again, and this is just going to get longer and probably repeat after a while. So it doesn't seem like this is solvable. Well, it is. Think about this as an algebraic function. Okay, notice that we have the integral e to the x sine of x dx on this side, and we have the integral of e to the x sine of x dx on the other side. They're the same. So why not we just add, as if it's just like simple algebra, if we add this to both sides. And when we do so, this is what results. That cancels, and we're left with 2 times the integral e to the x sine of x dx, and that's going to equal, now I'm just going to factor out the e to the x here, and we're almost done. Just divide both sides by 2, or multiply by 1/2. Same thing. And we're left with the integral of e to the x sine of x dx equals e to the x over 2. And just to avoid the negative being in the front, I'm just going to use the, just going to put sine first. Minus cosine x means the same thing. Plus c, constant of integration. And look right here. That is the original problem. We set the original problem equal to something after all this work. This is the original problem. It equals that. That's the answer right there. And that, I do 100% agree that it just takes practice for some of these problems. Take it from me, I took tons of math and science courses and other courses that just require practice and skill, like juggling and music, playing piano. I mean, it just takes a lot of practice. Whatever it is that you want to do in life, whatever your major is, just don't give up if it's truly what's in your heart. So, have a nice day.